All right, topic one, attributes of exponential functions. They're exponential functions. So here is the equation for an exponential function. It is y equals a times b to the power of x. Let me explain it, then you can pause it and write it out. Jeez Louise. All right, so a, what does a stand for? A is going to be your initial value, right? So a is your initial value, and then b is your base. And then how do we find A and how do we find B? So this is how we know what A is. It's my y-intercept. So if I'm looking at a graph, right? If I'm looking at a graph, it's this point right here. If I'm looking at a table, like if I was X and Y, you would want to find when your X value is 0, and then this would be like 1. Okay, so this is what you're looking at. All right, so here's your B, which is your base. And how do you find your base? You take it like this. It's the new Y value divided by an old Y value. So if I'm looking at a table, bam, right, here's my X and my Y. Let's say this is 2, 3, and this is 4, 5. These are my Y values, right? So you do new Y value divided by old Y value. So then you would do 5 divided by 3, because this is going to be your new one, because we're working this way like this. And then it'll be 5 divided by 3, and then you have your b. We're going to do problems like that. X is your exponent. All right, let's look at an actual graph for an exponential function. Bam, so we have parts of an exponential function. So we got to figure out, what does this mean and what is this dashed line right here? So this is what your graph looks like for an exponential function. It'll go like this, and the other way we'll see it will go down like this. Okay, so we have two ways we'll see it. Right now, this is a positive one. So what is this specific part right here we're talking about? This is my y-intercept. Y-intercept. All right, so this is my y-intercept. Ooh, that is not spelled right. Intercept. Bam. All right, so this is my y-intercept. What we're actually talking about is my initial value, right? So when I'm looking at a graph, so initial value. Bam. So I'm looking at a graph. This is what I'm trying to find right here, the initial value. Okay, now what is this right here, this dotted line right here? This is called asymptote. A-S, whoa, what's that S? A-S-Y-M-T. Ooh, how do you spell asymptote? I'm about to find out real quick because I have no idea. P-T-O-T. P-T-O-T. Dang, can't spell. Asymptote. Yeah. So this right here is an imaginary, it's a line that your graph never touch. So it's a line that your graph never touches. All right, so here's what I mean. This blue line right here will never touch this asymptote, meaning this asymptote is just this axis right here. What is this? The x-axis. It's going to get super, super close to it, but it'll never touch your graph. It looks like it's touching here, but if we were to zoom in really, really close, it should not be touching. So that's what it is. So we have an asymptote, which is this right here, and now this asymptote happens to be y equals 0 because it's crossing my 0 line, right? So it's y equals 0. Bam. All right, so here are parts of it. So you have an asymptote, you have a y-intercept, and your graph either goes up like this or it'll come down like that. And then lastly, here are the other parts of it. So you got to find your domain and your range. Ooh, come back, come back, come back. Let's think about this domain and range. Domain and range. So first, domain is going from left to right, right? So I scan from left to right. So I draw my line, bam, bam, and I say, can this be, is this the farthest my graph goes, like right here? Can I put a line and say it stops here? And we say no, right? Because what does this arrow mean right here? It's going to go on forever and ever and ever. So we know for it goes to negative infinity. Can I draw a line here and say, hey, this is where my graph stops? No, because this arrow also indicates that it's going to go forever, ever up. So if it goes to negative infinity to positive infinity, what does that mean? That's all real numbers. All real numbers. That I cannot write today. Bam, all real numbers. If you remember, it is this sign right there. Okay, so now range is how high and how low does it go. So let's think about this real quick. Let me erase this, bam. So range is what's the highest and the lowest. Look, the lowest it goes is here, right? What is this again? This is 0 because we're talking about y values, so range is up and down. All right, now what's the highest it goes? Can I put a line here and say that it stops here? No, because we know this arrow means it's going to go up forever up, which means it's going to go to positive infinity. Okay, so my y values, they have to be greater than 0. So my y values have to be greater than 0. So we can do 0, positive infinity. Y value goes in between here. Bam, bam, and you write it like this. We're not going to do the equal to like with this. We're not doing that because your graph, this graph right here, will never touch this line that I'm drawing. It should never touch it, so it's not going to be equal to. It's just going to be like that. So there's your range. All right, so here are the parts. Let's do some problems real quick, and then we're done. So I'm looking at this. We need to come up with a table. We're going to graph this table, and then we're going to come up with its increasing, decreasing, and asymptote and all that other stuff. All right, so step 1 is to plug it into your calculator. So step 1, we'll put calc. So here's what we're going to do. Bring out my calculator. Make sure you guys have your calculator. Bam, here's my calculator. And I'm going to type this into y equals. So put y equals. That's where I'm typing it in. Calc y equals. Bam, here. So real quick, on your paper, this should be a times. Right, I messed up for some reason, some box, but it should be times. All right, so then let me actually write that. This is times. So make sure you fill that in. All right, so when I plug it into my calculator, here's what I'm going to do. 3 times 2 to the power of x, to the power of x. Now, real quick, let me show you how I got that. I think a lot of you kids are like, what in the heck? How'd you do that? So, come on, mouse, work, work, work. All right, here we go, my bad. So, bam. All right, cool. So how did I get this little x up here? So first of all, let me delete it. I'll delete it again. You hit this little caret key right here. On top of the divide, you hit this. And I'm going to hit x, which is right here. Bam. So now I have 3 to the power of x. All right, cool. So next, what we want to do is we want to look at the table. And if table was blue, I have to hit second graph to look at my table. All right, so let me move up a little bit so we can help fill out my table. So when my x is -3, what's my y value? Bam. So we're writing all these numbers onto here. So let's go and do that real quick. So we got 0.375, 0.75, 1.5, 3, 6, 12. All right, cool. Now we're going to graph this real quick. So let me actually move this away. Now we're going to graph. I know you guys' paper, when I printed it, it kind of sucks. You can't really see it, but try your best. So we need to graph these points onto here. Just try your very best. All right, so we know -3, 0. So notice this is -3. Trying to do a small dot. -3, so I'm going to say that it's like right here. -2.75, I'm going to say it's like right here. -1.15, and here's 1.5, bam. 0, 3 was right here. Whoa, whoa, whoa. And 1, 6 is right here, and then 212 is right here. Okay, so here's my graph. Now we got to draw a line through it. Let's draw a line real quick. So it's going to look like something like this. Bam. All right, so here's my graph like this. Notice I did not touch. It should not be touching. This graph should not be touching this line here. It will never touch it. That's just part of the exponential function. So real quick, I'm going to draw a little dashed line so you guys know this should not touch. Bam. All right, cool. And then let's just do, this is called asymptote, A-S-M-P-T-O-T-E. Damn, I keep messing up. P-T-O-T-E, asymptote, and it's y equals 0. All right, so here's your graph. Now let's fill it out real quick. So the question says increasing or decreasing. Again, if I'm going too fast, guys, just pause the video and fill it out and then play it again. Increasing or decreasing. So when we look at the graph, we start from the left and we go to the right. So as I go from the left to the right, notice how it's going up. So this is increasing, right? So I'm just going to circle that. That's increasing. Okay, and then it asks me, what's my y-intercept? Now remember, your y-intercept is when you have your x value 0. Put that on your paper. So what is your x value 0? This right here happens to be your y-intercept, even if you were looking at your table. And then here's your y-intercept, bam. Right, those two are the same points. So your y-intercept is 0, 3. What's your asymptote? We just did that. This right here is your asymptote. It's the line that your graph never touches. So then it's going to be y equals 0. What's your domain? How far left do you go and how far right do you go? That's your domain. So look, it's going to go forever to the left and forever to the right because it's going to keep going that way. So this is going to be all real numbers. All real numbers. Or you can do this. and your range is how high and how low. So this is the lowest it goes, and it goes forever up. So it's just like the original one. So it's going to be y values greater than 0. All right, cool. Let's do one more, and then you guys can start your practice. All right, so here we go. Same thing goes. I want you guys to actually try this yourself. So you're going to plug this into the calculator, step one. You're going to look at the table. You're going to graph it, and then do this, and press play to check your answers. So step one is plug into the calculator. So here we go. So bam, go over here, go back to y equals, see, y equals, bam. Let me clear this out. So delete. Now I need to type this into here. So 4 times, we need a fraction. So I'm going to hit alpha y equals. I want the fraction, bam. So then let's do 1 over 2. I could include the parentheses. I should actually, let me actually go and do that real quick. Parentheses here. And parentheses here, and then we're going to do to the power of x. All right, so then let's go ahead and do that and press, now I want to look at the table, right? I can hit the graph. This is what my graph looks like right here. All right, so then if I hit second graph, let's fill out my table. So -2, let's start there. So now I'm going to put these y values right here. So we got 16, 8, 4, 2, 1, 0.5. All right, now step two is this is step one. Here's step two. We need to graph these points onto this. Super easy. All right, let's go ahead and do it. -2, 16. So -2, 16. So here's -2. So here's the way we do it. If you get -2, you go this way. 16, you go up. So here's your first point. So -2, 16 here. So then -1, bam, 8. So you go up. Here's your point right here. All right, 0, 4, bam, 1, 2, bam, 2, 1, bam, and 3, 0.5, bam. All right, cool. So now we go ahead and just trace my line, and it goes like this. So I actually lied to you guys in the beginning. This is the decreasing one. I was looking at a different graph. I was thinking about a different graph. All right, so here is the decreasing graph. Now let's go ahead and draw my asymptote because we know it's going to be the same thing. Bam, bam, bam. This is the line. That's your graph. The black picture never touches. So y equals 0. This is your asymptote. Bam. Okay, cool. Now let's fill it out. Fill it out. All right, so as we go from left to right, does your graph look like it's increasing or decreasing? It's going down. So this is decreasing. Bam. So let's go ahead and circle that. So this is decreasing. All right, so what is your y-intercept? Your y-intercept is when your x value is 0. So you have 0 comma a number, right? So then what is my, we know it's right here too, right? This is your y-intercept. Here's your y-intercept. So this is 0 comma 4. All right, next. Asymptote, we already know it's y equals 0. Domain, it's the same thing, right? It's going to go forever left to forever right, so it's all real numbers. Your range is the same too. Look, your range is going to be, it's not going to go past this line. It's going to go forever up. So it's all your y values greater than 0. Or you can write like this. Same thing, same thing. All right, these are your notes. Here is your homework. I'll kind of show you over it. So this is the same thing. On your homework assignment right here, can you actually change this to a times? Because that should be a times. You're going to plug in the calculator. You're going to fill in these tables, and you're going to draw it, and you're going to do that. This one right here is a problem that I want you guys to try to figure out. So it says Kayla has 3 bunnies in her yard. I'll kind of help you out. It says each of these bunnies has 2 bunnies on their own and does not have any other bunnies. If the trend continues, how many bunnies are born after 5 generations? So I'll help you start the first 2 generations. So let's think about this. Homegirl found 3 bunnies, right? So here's 1 bunny, here's 2 bunny, and here's 3 bunnies. All right. Then it says each of those bunnies had 2 babies. So here's this homegirl, 1, 2, bam. And then this girl had 1, 2, bam. And then this girl had 1, 2, bam. All right, cool. So then it says how many bunnies will be born after the first generation? So this right here, this first one, this is generation 1. This is G1. All right, generation 1. Okay, so then this right here is G2. It says generation 2. That's not a 2. Bam. So then you had to keep going. If the trend continues, meaning if this baby had 2, and this baby at 2, and this baby at 2, and this had 2. So this would be generation 3. So I'm going to do highlight in yellow. And then we need a different color because we need to do generation, let's get blue. So we need generation 4, and then we need one more generation. You have to do it one more time, I know. And then we do generation 5. So you're going to have to multiply this one here. This has 2, and then this one has 2. So you got to do that for all of these to figure out. Oh, my bad. Generation 0. Oh no, I messed up. So 5 generations. So the original one is the starting one. My bad. So this is actually G0. This is G0. So this is G1. This is going to be, yellow's going to be G3. This is G4, G5. All right, bam. All right, so that's how you do it right there. So then generation 1 has 3 bunnies. And generation 0, the first starting one, has 3 bunnies. Right, this one right here. All right, so then generation 1, which is after the first 3 bunnies, that's 6. And then you figure out how many go in yellow, how many are in blue, and how many in the dark pink. And that's how you do this. All right, guys, good luck.